Could you take a submarine, point it at the stars, and blast off? It sounds like a wild sci-fi movie plot, but let's actually break it down. Can a machine built to conquer the crushing depths of the ocean survive the vast emptiness of space? The answer is a lot more complicated and fascinating than you might think. First, let's talk about what submarines and spaceships have in common. They're both life support systems. A submarine keeps its crew alive in an environment that would instantly kill them. The deep ocean has no breathable air and immense pressure. Space has no breathable air and basically zero pressure. Both vessels are designed to be self-contained bubbles of life, managing air, water, waste, and temperature for the people inside. So, on a very basic level, they share a core purpose: keeping humans alive where they shouldn't be. A nuclear submarine, for instance, can generate its own power and oxygen for months on end, which sounds pretty useful for a long space journey. But that's where the similarities start to fall apart, and the problems begin to pile up. The biggest, most immediate problem is pressure. Submarines are built to withstand immense external pressure. Their hulls are incredibly strong, usually rounded cylinders, specifically to resist being crushed. Space is the exact opposite. It's a vacuum. Inside the submarine, you have 1 atmosphere of pressure pushing outwards, and in space, you have 0 pressure pushing inwards. The submarine would essentially be trying to explode. While the hull is strong, it's designed for crushing, not for this kind of outward force. Every window, every hatch, every seal would become a weak point, potentially leading to a catastrophic failure. Then there's the issue of getting there. Spaceships are built to be as light as possible. Every single kilogram costs a fortune in fuel to launch into orbit. Submarines are the opposite. They are incredibly heavy. A U.S. Virginia-class submarine weighs nearly 8,000 tons. Just imagine the rocket you would need to lift that. It's beyond anything we can currently build. The submarine's dense, thick hull, perfect for the deep sea, becomes a massive, immovable anchor on the launch pad. Let's say we magically teleport our submarine into space. Now we face a whole new set of challenges. Temperature control, for one. In the ocean, water is a fantastic coolant. It constantly carries away the heat generated by the reactor, the electronics, and the crew. In the vacuum of space, getting rid of heat is a huge problem. Spaceships use complex radiator systems to bleed heat into the void. A submarine has no such system. It would slowly cook its occupants. When in the shadow of the Earth, it would freeze. The temperature swings are extreme, and a submarine's systems just aren't designed for it. What about navigation and movement? Submarines use propellers to push through water. In the vacuum of space, propellers are useless. There's nothing to push against. Our submarine would just be a tumbling piece of metal. It would need a full suite of thrusters, gyroscopes, and a sophisticated navigation system just to point in the right direction and move around, none of which it has. And don't forget radiation. Earth's atmosphere and magnetic field protect us from the sun's harsh radiation and cosmic rays. A submarine's hull offers some protection, but it's not designed to block the high-energy particles that flood space. Over time, the crew would be exposed to dangerous levels of radiation. So, while the idea of a submarine in space is incredibly cool, the reality is it just wouldn't work. It's the right tool for the wrong job. Submarines are masterpieces of engineering, perfectly adapted for the crushing dark abyss of our oceans. Spaceships are equally incredible, designed for the vacuum, radiation, and extreme temperatures of the cosmos. They are 2 different answers to 2 very different, but equally hostile environments. Thinking about this really shows us how challenging exploration is. It's not just about building a strong box. It's about understanding the specific, brutal physics of the environment you're trying to conquer. The deep sea and outer space might both be deadly frontiers, but they demand completely different survival strategies. Each requires its own unique kind of vessel, a testament to human ingenuity in the face of the unknown. So next time you see a submarine, appreciate it for the deep-sea explorer it is, and leave the starfaring to the rockets. Thanks for watching.